Electric field due to an electric dipole at a point on the equatorial plane. There are 2 point charges minus q and plus q at A and B separated by a distance of 2a. O is the midpoint of these 2 point charges and the electric dipole moment P vector acts from minus q to plus q. Let me consider a point C just above the midpoint O and perpendicular to the axial line. I call it as C. This is at a distance r. So there is a plane which is perpendicular to the axial line and passing through this equatorial line is called equatorial plane. Any points on this equatorial plane are at equal distance from minus q and plus q, which is equal to root of r square plus a square. In finding the electric field intensity at C, we need the square of the distance between the charges. So we have to square root of r square plus a square. So we have r square plus a square as the distance square. Now let us find what is the electrical field intensity at C due to plus q, which is away from the positive charge, which is represented by E plus vector. Let us find what is the electrical field intensity at C due to minus q, which is towards the negative charge. We represent it as E minus vector. We resolve these two components, we resolve these two vectors and we find the resultant which is acting along the negative x-axis or against or opposite to the P vector. We call it as E vector, which is nothing but the electrical field intensity at C on the equatorial plane. The angle theta, cos theta equals adjacent side A by the hypotenuse root of r square plus a square. We will be using this in a derivation. The magnitude of E plus vector and E minus vector are same. Their directions are different. So E plus magnitude equals E vector minus magnitude equals 1 by 4 pi epsilon naught into the source charge q by the distance square, that is r square plus a square. The direction of E plus is along BC, that is away from positive charge, and the direction of E minus vector is along CA, that is towards the negative charge. So at the point C, there are two electrical field vectors are acting. One is E plus vector, the other one is E minus vector. The E plus vector makes an angle theta with the horizontal. So we resolve this E plus vector into two components. One is along the negative x-axis, that is minus the modulus of E plus vector cos theta I. Another one is the vertical component along the positive y-axis. So we write E modulus of E plus vector sin theta j cap. Let us now resolve the E minus vector into two components. One is along the negative x-axis, that is minus E vector minus modulus cos theta I cap, and another vertically downward, that is negative y-axis. We write it is minus modulus of E minus vector sin theta j cap. From the diagram we understand that the vertical components are equal and opposite, so they cancel each other, and the E plus and E minus vectors are no more available. We have only the minus modulus of E plus vector cos theta I and minus modulus of E minus vector cos theta I along the negative x-axis, that is opposite to electric dipole moment vector. So E equatorial, we are adding the two electric field at C due to 2 point charges minus q and plus q each. So E minus vector is resolved into two component and E plus vector is resolved into two component. In that we found that the sin theta components cancel each other. So only the cos theta component will be added. So we get E equatorial vector equal to minus 2 E plus vector modulus cos theta I cap. We know that E plus vector as 1 by 4 pi epsilon naught q by r square plus a square, whereas the cos theta is replaced by a by root of r square plus a square. On simplification, we get E equatorial vector equals minus 1 by 4 pi epsilon naught 2aq by r square plus a square to the power 3 by 2 I cap. Now we can replace the 2aq I cap as p vector. So the final equation is E equatorial vector equals minus 1 by 4 pi epsilon naught p vector by r square plus a square to the power 3 by 2. When the distance r is very small, when r is very great compared to a, then we can neglect the a square. So the final equation is E equatorial vector equals minus 1 by 4 pi epsilon naught p vector by r cube.